Welcome back. This will be the last part of our lecture 4.1, distance problem. Now, this is a particular example you might or might not understand. If you don't understand, don't worry about it too much. When we do our problems, you will understand it better. Okay? So, distance problem. Find the distance traveled by an object during a certain time period if the velocity is known. Okay, usually if you're given distance you can find the velocity, but what if you know the velocity? You need to come back to distance. If the velocity remains constant, then the distance problem is easy to solve. Distance is velocity times time. I hope this is clear. You see, uh, let me use the screen. You have speed is a fraction of distance over time. So distance equals speed times time. That's all we are saying. Okay, this is the case. So distance would be given to you if speed were say 30 miles per hour. Then given time you can find how much distance you have covered. This makes sense if you're driving at 30 miles per hour for the entire duration of the time. Suppose you're driving 30 miles per hour for 1 minute, then 32 the second, 35 the third, and then 29 the fourth, and so on. Then this formula doesn't work because the entire time period of 1 hour or 2 hours, your speed has been changing. All right. So the problem is easy if the speed is constant. That's all they are saying. But if the speed, velocity, so what is velocity? Speed with a direction. Okay. So if the velocity changes, it is not so easy to find the distance traveled. So here is an example. So suppose your odometer is the gadget in your car which measures your speed or velocity. Suppose we want to suppose the odometer on our car is broken and we want to estimate the distance driven over 30-second time interval. Oh, sorry. Speedometer is what measures speed. Odometer measures distance. Okay. So we don't know the distance based on our odometer, but we want to use the speedometer. All right. When time is 0, so at the beginning you start at 17 miles per hour. When time is 5 seconds, you're at 21 miles per hour. 10, 24 miles. So notice your speed or the velocity has been changing with respect to time in seconds. Notice velocity is in miles per hour. You want it per second. Okay. It's better to have feet per second. This is standard. Now 1 mile per hour is 5,280 per these many seconds, 3,600 feet per second. Okay, so that's because 1 mile is 5,280 feet, 1 hour is 3,600 seconds. So you can convert from miles per hour to feet per second by simply multiplying by this quantity. 17 times this fraction is approximately 25. 21 times this fraction is approximately 31, and so on. Okay, go from here to here. So you now have a table which gives you time in seconds and velocity in feet per second for those times. During the first 5 seconds, the velocity doesn't change much. So we can estimate the distance traveled that time by assuming that the velocity is constant. So we are taking 25 feet per second times 5. So 0 to 5, so here 0 to 5, Pretend you are at 25 and you change your speed at 5. That's what they are doing. So for the first 5 seconds, you're assuming your velocity is 25 feet per second. Use that. That is the distance traveled in the first 5 seconds. Now, the next batch of 5 seconds, we use 31. Why? Because look, at 5 seconds, we are assuming the velocity is 31, and we assume that 5 until 10 seconds, we are at 31. Okay? So, the next 5 seconds, that is from 5 to 10 seconds, is 31 feet per second times, and so on. So you're adding the first 5-second distance plus the next 5-second distance, the next 5-second distance, and so on. Okay, using this table. So 25 for the first 5 seconds, 31 for the next 5 seconds, 35 for the next, 43 for the next, and so on. All right, that gives you a certain estimate for the total distance traveled. Okay. On the other hand, we could have chosen the higher values. That is, we could have assumed from 0 to 5 you were 31. From 5 to 10 you were 35. 10 to 15 you were 43. 15 to 20, so on. Okay. You could have assumed a higher number. All right. That would have given us another estimate, which is a higher estimate. If we wanted a more accurate estimate, we would have taken velocity readings every 2 seconds or even every second. You see, why 5 seconds? Every 2 seconds or every second. So in general, suppose an object moves with velocity v from an interval a to b and f of t is positive, greater or equals 0. Okay, so you are assuming your object is moving in the positive direction. We take velocity readings at time t naught, that is the beginning time, then t1, t2, so on until the nth time tn, so that the velocity is approximately constant on each subinterval. If these times are equally spaced, like in our example, time was equally spaced, 5 seconds each. Suppose if your time is equally spaced, then the time between consecutive readings, so there are n cuts here, n pieces. So b minus a is the total length over n. During the first time interval, velocity is, let's assume, at the 0th. So from 0th to first time, velocity is what you say at this point. Okay, at that time. So you have traveled this much distance in the first split of your time. Okay, and then continuing. For every split, you're taking a particular time. So for the first split, t0 to t1, you're assuming this is the velocity, ft0. For the second split, t1 to t2, you're assuming ft1 is the velocity, and so on. Okay, and or you could start from the right hand side. So this is the left endpoint sum. You could have taken the right endpoint sum, that is in the very first interval you are choosing ft1. So in this interval t0 to t1, you are choosing this velocity at time t1. T1 to T2, you are choosing T2. So right endpoint velocities. You could have chosen that as well. So you have one estimate for the left endpoints, another estimate for the right endpoints. Okay. So the total distance is the limit of these sums as n approaches infinity. All right. So that ends our lectures for section 4.1. The next slides will be problems from web work. Okay. Until then, by the way, keep looking at these lecture slides. If you have any questions, do not hesitate to write to me, or let's meet on Blackboard Ultra.